Today we're going to be completing our notes on 9.1, solving quadratic equations using graphs and tables. I want to start with this example. Look at the path of a golf ball that's hit from the ground and how it resembles the shape of a parabola. The trajectory of the ball, or the height of the ball at any given time, is modeled through a quadratic function, where the graph is the shape of a parabola, that upside down U shape. So I want to know what point represents the golf ball before it's hit off the ground. So looking at this diagram here, given these axes right here, this horizontal axis being the x-axis and the vertical axis being the y-axis, the point that the golf ball starts is the origin, 0, 0. The point where it hits the ground, once the player hits the ball, it goes up all the way up into the air and then it starts coming back down. It hits all the way out here where our sign here shows 200 yards. And so the coordinates for this point, if we were to overlay this onto the coordinate plane, the point would be 200, 0. Okay. So this is modeled, this x and y value. The x value is the distance away from the golf player. So 200 yards. And then the y value is the height over time. Okay. Now let's take a look at some of these graphs. So solutions to a quadratic function are shown as x-intercepts on the graph. Okay, so if we find the x-intercepts on the graph, this tells us solutions for the quadratic equation. So looking at the first one, we have x-intercepts right here and right here. Now I know that every tick mark is 2 because it takes 5 tick marks to get up to 10. So that tells me that we have solutions at positive 4 and negative 4. Okay, so solutions, x equals 4, x equals negative 4. We would write these as x-intercepts, 4, 0, or negative 4, 0. So I'll write both forms here as intercepts, but also as solutions. Okay. For the next one, we've got one x-intercept. It crosses the x-axis once, or touches the x-axis once. Each increment is 1 because it takes 5 marks to reach 5. So that tells me that this is at x equals 7. As an ordered pair, this is 7, 0. And finally, for graph C, I notice that it doesn't touch the x-axis at all. So therefore, there are no solutions to this quadratic equation, or at least the equation that has this graph. Example 2, again, we're looking for those x-intercepts, but now we have tables of values. Now, as a reminder, an x-intercept is anywhere where y equals 0. Okay, so I'm just going to write a note here. X-intercepts is where y is equal to 0. So looking at our tables of values in table A, I notice y equals 0 in the second row here, and then the second to last row here. So that tells me we have solutions at x equals negative 2 and x equals 3. As ordered pairs, negative 2, 0, or 3, 0. For table B, again, we're looking where y is equal to 0, or the h of x value is equal to 0. The output of the function is equal to 0. And we have that this occurs at 2 places again. We have at negative 1, so x equals negative 1, and x equals positive 1. So as ordered pairs, negative 1, 0, and 1, 0. Okay? Go ahead and flip the page. Example 3. Anastasia hits her golf ball off the tee. The height of the golf ball is modeled by the function f of x, where x is the number of seconds after the golf ball is hit. How long is the golf ball in the air? Okay. So in order to graph this, I notice that Anastasia hits the golf ball off the tee and it goes up into the air and then it lands somewhere out there. Where this is modeled by f of x is equal to negative 5x squared plus 25x and then plus 1. Okay? So in order to find how long the ball is in the air, let's go ahead and graph this on our TI Inspire. Go ahead and take out your calculator. Once you have your calculator out, go ahead and open up a new document, and we're going to add a graph here. In the function up here where we have f1 of x, we're going to go ahead and type in our function. So negative 5x squared, and then plus 25x, and plus 1. If you hit enter, we can see the graph right here. Now we're not going to see the whole graph, but we do see the x-intercepts. So I notice that we've got one, it appears at the origin, and then we've got another, it appears to be at about 5. But let's go ahead and check for sure. All right, so to check, we're going to hit menu, and we're going to go to analyze graph. Okay, we want to know where the x-intercept is. Another name for this is the 0 of the graph. So of course we have a 0 or an x-intercept right over here, just before the origin, but we've got another one out here. So this is the starting value, and then this is the ending. In order to find the 0, we need to choose a lower bound and an upper bound. These are just x values that are before and after, less than and greater than the 0. Okay, so I see that the 0 occurs here. Doesn't matter really how close you get to the 0. So a little bit to the left of the 0 and a little bit to the right. The point here is just make sure that you have the 0 in between the lower and upper bounds, or in the shaded region. So using our calculator, we find that this 0 or x-intercept occurs at 5.04. So let's go ahead and write this. We have an x-intercept at 5.04, comma 0. Okay? So because x is the number of seconds that the ball is in the air, and I know that the height is modeled by f of x, the height is 0 after 5.04 seconds. Or in other words, after 5.04 seconds, the ball hits the ground again. Okay, so it's in the air for about 5.04 seconds. All right, let's get some practice. So we're going to graph each of these in our TI Inspire calculator, and then we're going to find the x-intercepts. So we'll start with this one, x squared minus 3x minus 10. Back to our calculator. In order to get back to the function, you're going to hit the tab button, and then I'm going to go back up to f1 of x. So we're done with this one, so let's go ahead and clear that out. We'll type in the next one, x squared minus 3x minus 10. Hitting enter, we have this here. Let's go ahead and find this other 0. So back to menu, analyze graph, 0. And choosing a lower and upper bound, highlighting that 0. We have two zeros, one at -2 and one at 5. So solutions, x equals -2, x equals 5. And as ordered pairs, we have -2, 0 and 5, 0. All right. Next up, -x squared plus 2x. Back to our calculator. Tab to get back to our function. So that was -x squared, and then plus 2x. Hitting enter. We got to find these zeros. So menu, analyze graph, 0. We're going to do the first one right there. That's the origin. Menu, analyze graph, and 0. We'll do the second 0 right there. So we have one at the origin and one at 2, 0. It's important to use that analyze graph feature because while it does look like the origin and 2, 0, we can't say for sure, right? It could be maybe 0.00001, 0 for this first one. So it could be really close to 0, but not exactly. We use the analyze graph tool to find exactly what that 0 is, and we do confirm that it's at 0 and 2. Okay? So x equals 0, x equals 2. So the origin and 2, 0. Okay. Next up, we have x squared plus 2x plus 4. So back to our calculator, tab. We're going to clear out that function. X squared plus 2x and then plus 4. Looking at the graph here, I notice that it doesn't touch the x-axis at all. And so this is like the example that we had earlier. This has no x-intercepts, so therefore there are no solutions. Okay, you can write no solution, you can write none. And last one here, we have f of x equals -x squared plus 2x minus 1. All right, so back to our function. This actually looks pretty similar, so I'm going to go ahead and make those changes. We have a negative leading coefficient and then a -1 for the constant term. Hitting enter. It looks like we have 1, but let's go ahead and use analyze graph and 0. to find exactly what that x-intercept is, and we find that it's 1, 0. Okay, so x equals 1, we have 1, 0. All right, so these have been our notes on using graphs and tables to find the solutions to quadratic equations. We're going to get a lot of practice, so we'll see you tomorrow.